Once again, I welcome in the course of Foundation Engineering. So in the last class, I have discussed the mass spring model in forced vibration, and then I will discuss the mass spring dashpot model in free vibration and forced vibration. And after that, I have derived the different important parameters and then problems based on this model. Today I will discuss the what is transmitted force, and then what is force transmissibility, and then what is the Barken's method and how to compute how to compute the coefficient of elastic uniform compression, and then I will discuss the amplitude ratio and what is the relationship between the logarithmic decrement and damping ratio, and then I will solve the problem based on this method. So let us start about the transmitted force. So in a damped force vibration system, the support is derived from the foundation by way of transmitting a force of the to the foundation. So this transmitted force can be written as sum of damping force, that is C into Z dot plus spring force, or we can write Ft is equal to C dz by dt plus kz. So if I write the transmitted force, the solution here, so Ft is equal to F naught into N into 1 plus 4 eta square into R square. So this is the Ft is the transmitted force, F naught is the exciting force or unbalanced force, and N is the magnification factor. So if I write Ft is the transmitted force, F naught is the force of exciting slash unbalanced force, and eta is the damping ratio, and R is the frequency ratio. The ratio of the equation can also be written as Ft by F naught. So Ft by F naught is equal to N into a square root of 1 plus 4 eta square into R square, and this Ft by F naught is called transmissibility force. So Ft by F naught is equal to T is equal to N square root of 1 plus 4 eta square into R square. Where T is the transmissibility force, N is the magnification factor. So this is this relation we have to remember, either the expression of transmitted force, that is F naught into N square root of 1 plus 4 N square R square, or the expression of force transmissibility. Now I am going to derive the natural frequency of foundation soil system. So the natural frequency, we know that omega n is equal to K by M. So for the foundation soil system, this mass can be written as mv plus ms. So where mv is the mass of vibrator, and ms is the mass of soil. So this natural frequency can also be written as K divided by mv plus ms. Now I am going to discuss the Barken's method. Barken method. In 1962, the Barkens has given the expression of natural frequency. According to Barken, omega n is equal to square root of Cu into A divided by M, where Cu is the coefficient of elastic uniform compression, and here the A is the contact area. A is the contact area of foundation with soil, and M is the mass of machine plus foundation. So this the Barken in 1962, this expression was given in 1962, and according to Barken, the natural circular frequency is equal to square root of Cua divided by M, where Cu is the coefficient of elastic uniform compression of soil, A is the contact area of foundation with soil, and M is the mass of machine plus foundation. Similarly, the amplitude can also be computed. So the amplitude of displacement can also be computed as Az is equal to F naught by M omega n square into 1 minus R square, where F naught is the exciting force, R is the frequency ratio, omega is the natural circular frequency, and M is the mass of the system. So this amplitude can be computed by this expression. Similarly, Barken is given the relationship between coefficient of elastic uniform compression of soil, that is Cu, and this Cu can be computed as 1.13 E divided by 1 minus nu square into 1 by root under A. With the help of this expression, we can compute the coefficient of elastic uniform compression, where E is the Young's modulus of soil, nu is the Poisson's ratio, and A is the contact area. So with the help of this expression, we can compute the coefficient of elastic uniform compression of soil. There is another very important term that is called amplitude ratio. This amplitude ratio AR can be computed as AR is equal to R square divided by square root of 1 minus R square to the whole square plus 4 eta square into r square. So with the help of this expression we can compute the amplitude ratio, where r is the ratio of omega by omega n, or f by fn, that is called frequency ratio, and eta is the ratio of actual damping by critical damping and called damping ratio. There is another terminology that is called logarithmic decrement. Logarithmic decrement delta. So let us discuss about the logarithmic decrement delta. So logarithmic decrement can be computed as delta is equal to ln a2 by a1. So we can compute delta is equal to ln a2 by a1. What is a1 a2? So we can write a1 and a2 are the amplitude of two consecutive amplitude response curve. So a1 and a2 are the amplitude of two consecutive cycle of amplitude response curve. So there is a relation between the logarithmic decrement and damping ratio. So what is the relation of logarithmic decrement can be written as also 2 pi eta divided by square root of 1 minus eta square, where eta is the damping ratio and delta is the logarithmic decrement. So let us take the few problems based on this. So the first problem I have taken, that is determine the natural frequency of a machine foundation having a base area. So base area is given 2 meter by 2 meter, means 2 by 2, it is 4 meter square, and a mass of 15 mg including the mass of machine, taking coefficient of elastic uniform compression is 4 into 10 to the power 4 kilonewton per meter cube. So if I convert in Newton, so 4 into 10 to the power 7 Newton per meter cube, and the mass can be written as 15 into 10 to the power 6 gram. So it will be 15 into 10 to the power 3 kg. So according to Barken's equation, according to Barken's method, omega n is equal to a square root of CUA divided by m. So it will be Cu is 4 into 10 to the power 7. So 4 into 10 to the power 7 into area is 4 and the mass is 15 into 10 to the power 3. So 15 into 10 to the power 3. So the natural frequency is 16 into 10 to the power 7. 16 into 10 to the power 7 divided by 15 into 10 to the power 3. So it is 103.28 radian per second. So this is the natural circular frequency. Similarly, if I convert in cycle per second, so Fn can be written as 1 by 2 pi into omega n. So it will be 1 by 2 pi into 103.28. So it will be 103.28 divided by 2 pi. So it will be 16.52 cycle per second. Let us take the another problem. The natural frequency of a machine foundation is 4 Hz. So it is 4 Hz. Determine the magnification at the operating frequency. So operating frequency is 8 Hz. So frequency ratio is F by Fn. So it will be operating frequency divided by 4. So the frequency ratio is 2. And the damping ratio is also given 0.3. So the magnification factor can be computed as n is equal to 1 divided by square root of 1 minus r square whole square plus 4 eta square r square. So it will be 1 by square root of 1 minus 2 square whole square plus 4 into 2 square into 0.3 whole square. So it will be 1 divided by square root of 9 plus 4 into 0.3 square. So it will be 0.309 is the magnification factor. Let us take the another problem. Determine the coefficient of uniform compression if a vibration test on a block. Block dimension is 1 meter by 1 meter by 1 meter. So if I compute the mass of foundation block, so it will be mass of foundation block. So it will be 1 into 1 into 1 into 24 kilonewton per meter cube divided by 9.81. So it will be 24,000 divided by 9.81. So it will be 2446.48 kg. So the total mass is equal to 2446.48 plus the mass of oscillator is 60 kg. So it is 60 2446.48 plus 60. So it will be 2506.48 kg. So we have to find the coefficient of uniform compression. So according to Barken's method, omega n is equal to square root of CUA by m. So F can be written as 1 by 2 pi square root of omega n. So CUA by m. And frequency is given 30. So it will be 30 is equal to 1 by 2 pi square root of Cu into area 1 divided by mass is 2506.48. So Cu is equal to 30 into 2 pi into square root of 2506.48. So it will be Cu is equal to 89.06 into 10 to the power 6 Newton per meter cube. Let us take the another problem. In a test block of size 1.5 by 1 by 0.75 meter, resonance occur at a frequency of 20 cycle per second in the vertical vibration. Determine the coefficient of elastic uniform compression if the mass of the oscillator is 70 kg and the force produced by it at 15 cycle per second is 1000 Newton. Also compute the maximum amplitude at 15 cycles per second. So firstly we have to find the coefficient of elastic uniform compression. So mass of test block is equal to 1.5 into 1 into 0.75 into 24 into 10 to the power 3 divided by 9.81. So it will be 1.5 into 0.75 into 24 into 10 to the power 3 divided by 9.81. So it will be 2752.29 kg. So total mass is equal to 2752.29 plus mass of vibrator frequency itna determine the mass of oscillator is 70 plus 70, so it is 2822.29 kg. Once again if I apply the Barken's method, so according to Barken's method, omega n is equal to square root of CUA by M, and the resonance occur at a frequency of 20 cycles per second in the vertical direction. And we have to find the elastic compression if the mass of itna and the force produced it by 15 cycle per second is 1000 Newton. So firstly we have to find the it is 20 cycles per second, so it will be 20 is equal to 1 by 2 pi square root of CUA by M. So 20 is equal to 1 by 2 pi square root of CU into area is 1.5 by 1, so it is 1.5 divided by mass is 2822.29. So Cu is equal to 40 pi into square root of 2822.29. So it is 44.57 into 10 to the power 6 Newton per meter cube is the coefficient of elastic uniform compression. Similarly, the maximum amplitude can be computed as, so maximum amplitude can be computed as, let Amax be the maximum amplitude, can be computed as F0 divided by M omega n square into 1 minus R square. So omega n can be computed as 2 pi into Fn, so it will be 2 pi into 20, so it will be 40 pi. So omega n is 40 pi, so it will be 125.66 radian per second. Similarly, the frequency ratio can be computed as F by Fn. So it will be the frequency is 15 n by 20. So the frequency ratio is 15 by 20. So it will be 15 by 20, 0.75. So the maximum amplitude can be computed as exciting force is given 1000 Newton. So it is 1000 divided by total mass is 2822.29. So it is 2822.29 into omega n square. So 125.66 whole square into 1 minus r square. So r is 0.75 whole square. So maximum amplitude is 1000 divided by 2822.29 into 125.66 whole square into 1 minus 0.75 whole square. So it will be 5.13 into 10 to the power minus 5 meter. So it will be 0.051 mm. 0.0513 mm is the maximum amplitude.